Hello students, how are you? Hoping that all of you are very well at home and enjoying the life and then enjoying my video also, which is about the physics, both MBOSE student and CBSE, and I'm telling you. So in this video, like other video, I brought here the laws of reflection of light, the differentiate between real and virtual image, normal incidence, the lateral inversion, inverted image, and characteristic of image formed by a plane mirror. So these are the few of the topics which I want to bring you in this video, and you can learn this. This is very important for exams also. And understanding the physics, understanding the light, this is very important. These are the basic things of light, students. So let's start. What happens here, sometimes when you go to on the road and after a shower of rain, if some water is there, you get some, or on the road you get some shining thing. Rays of sun will fall on the road, a shiny road, and reflection, you get some reflection. The rays of light will bounce back and you can see the shining property of the road. So this is a example of reflection of light. We thought this reflection phenomenon is governed by a law. In the nature, everything is governed by a law. Sunrise early in the morning and sunset in the evening, there is a law of nature. So similarly, the reflection of light is also a law of nature. So let's start with the reflection of light. Okay, students. Okay, so students, now let's start with the reflection of light. As I told you that in the nature, you can get the phenomenon of reflection of light. After a shower of rain, the rays of light of sun will fall on the clean road. You get some reflection if there's a little bit of water remaining there. And similarly, you can see the rays of light striking on the surface of the mirror. It gets reflected back. So here, all these phenomena are guided by the laws. So law number 1, reflection of light. Suppose we take a plane mirror here. X and Y is a plane mirror. And on the plane mirror, one side is silver polish, we know that, and another side is reflecting if you have the looking mirror in a house. So law number 1 states that the point of incidence. Point of incidence is a point where the incident ray will strike. So this point is called as this point is called as the point of incidence. So at the point of incidence, the incident ray after striking will reflect back in the same medium. So this ray is called as the reflected ray. So the incident ray, the reflected ray, and the normal, the perpendicular drawn at the point of incidence is called as a normal. So normal ray here. So according to law 1, the point of incidence, the incident ray, the reflected ray, and the normal, they lie on the same plane. Okay, they lie on the same plane. Here we can see in the figure also. Yeah, all incident ray, reflected ray, and the normal are lying at the point of incidence, and they're lying on the same plane of the plane mirror. So this is law 1. Very simple to remember that at the point of incidence, the incident ray, the reflected ray, and the normal lie on the same plane. Law number 2. Here, the angle of incidence. Angle of incidence is the angle I here. Angle I. This is the angle I. No angle of incidence here. We can show you the angle I. And the angle of incidence. Angle of incidence is here. Angle PON is equal to angle I. Okay, this is the angle of incidence. No, so the angle of incidence, right? And angle of reflection. Angle of reflection is what? Angle of reflection is our angle. We see that angle NOR. NOR is equal to angle R. This is the angle of reflection. So angle R, no, angle R. So here NOR is equal to angle R is equal to angle of reflection. This is equal to angle of reflection. Okay, angle of reflection. And here, okay, this is the angle of incidence, angle angle of incidence, right? This is angle of incidence now. Okay, angle of incidence, right? So we can see here the angle of, according to law 2, the angle of incidence is always equal to angle of reflection. That is, angle I is always equal to angle R. So very simple to learn that. The angle of incidence is always equal to angle of reflection. So this is the law number 2. Very, very simple thing. The law 1, very simple. The incident ray here, okay, the reflected ray and the normal, they lie on the same plane at the point of incidence. And second law states that the angle of incidence is always equal to angle of reflection. So this is about the law. So now next we'll go to the image. Okay, next we want to go to define the image, right? We will go and define the image. Now image, how do you know? Suppose you stand near a looking glass, okay, or looking mirror in a house. You can see your image in the mirror. So now what is an image? How an image is formed? There is a very interesting phenomenon in nature, in the light. You see that now when the rays of light diverging from a point after reflection or refraction either actually meet at some other point or appear to meet at some other point, then that point is called as the image of the object. Okay, diverging from a point. So here, for example, the rays of light, this will be diverge from a point. No, this is diverging from a point. Okay, now here we can say that diverge. Okay, divergent rays. These are the divergent rays, diverging from a point. After reflection or refraction, they will diverge. And these diverged rays will either meet at a point. They will either meet at a point or appear to meet at a point. Okay, they will meet at a point. Okay, they will meet at a point or appear to meet at a point. This point is called as the image of the first point A. This point is called as the image of the point A. A1 is called as the image of the point A. So we will see it in the coming points here. So there are two kinds of images are there. One is called the virtual image and other is called the real image. Okay, images are of two kinds. Okay, images are of two kinds. One is the real image and other is the virtual image. Okay, now so look at the images now. Okay, now here image this is of the two kinds. Okay, right? Image is of two kinds, right? Images of two kinds. One is called as the real image and other is called as the virtual image, right? See, real image is always inverted. We can suppose there is a tree and real image of the tree will be inverted. Okay, and virtual image is erect, right? And real image can be received on a screen. On a screen we can see the real image. Okay, real image you can see on the screen and virtual image cannot be received on a screen, right? These are the two basic differences are there, real and virtual images, if you know that. So here real image is inverted and the virtual image is erect. Okay, real image can be received on a screen and virtual image cannot be received on a screen. So after that, let's see how so here first of all we'll go to the virtual image. We'll see how the virtual image is formed. So here you see the virtual image, when the rays of light diverging from a point and the rays of light diverging from a point, rays of light diverging from a point after reflection or refraction appear to diverge from another point, then the image so formed is called the virtual image. So here we can say the rays of light they are reflected. They are coming from the point O. These are the incident ray, and after striking a plane mirror, they will be reflected back. Okay, reflected back means they will diverge. They are diverging from the points from the point A and B. They are diverging. Okay, they are diverging. They are diverging means spreading. So after reflection, okay, or sometime it may happen refraction also, and they appear to diverge. Then after that, if you look at them, they appear to diverge from another point, from here, from the point I. From the point I, they appear to diverge once again if you look at them. So these the point I, from where the rays of light will diverge again, is called as the virtual image. This point is called virtual image. Okay, now and so now here we have to see the two basic things here. First of all, rays of light will reflect, and after reflection they will strike at the surface of the plane mirror. So from the points A and B, they will diverge again. They will diverge again after reflection. And when our eyes see them, they will appear to diverge from another point I. And this point I is called as the virtual image of the object O, right? Okay. Now, so here after that we'll go to. Okay, now here we look at a concave mirror. Concave mirror is a mirror which is reflecting inside. Inner side is reflecting, and outer side is polished. Okay, outer side is polished, and inner side is reflecting. This kind of mirror is called as concave mirror. So here, when rays of light coming from the object AB, these rays of light diverge from the object AB, and after diverging, they will strike at the mirror, at the reflecting surface of the mirror. After striking at the reflecting surface of the mirror, they will try to converge. They will try to meet at some other point, and this converging point or meeting point is called the real image of the object AB. Similarly, in case of refraction also it happens. In case of the refraction also it happens. They will converge at some other point. Okay, refraction, they will appear to converge at some other point. Suppose here refraction, we already know that there will be two medium. One is the rarer medium, other will be denser medium. So here the incident ray is coming. Okay, now here we can see that this is the medium of the air and water. Okay, this is air, suppose we can say. The water, we can say. We'll come to refraction chapter then there. It will be very good if you see that. So here just introduction I'm giving. So this is the incident ray, and after incident ray it will be refracted, and after refraction, if somebody want to see the image of the object in water, they can see them. They can see the image, and they will appear to converge here in some object. Suppose there is an object here. This object will appear here. Object will appear to raise. Raise at some other point. So here, this will come to the refraction chapter. Then we will do there. So here, just you have to know that when the rays of light diverging from a point. After reflection. So here we are showing after reflection or refraction. It is same. After reflection, refraction actually converge at some other point. So here, then the image so formed is called the real image. So here we can see that the rays of light are diverging from the point, from the object, from the point A, diverging, and after striking at the reflecting surface of the mirror, they will converge. These are the convergent rays. They will converge, and after converging they will meet at point, and this point is called as the real image of the object. B1 A1 is the real image of the object AB, right? So this is about the real image. So now here, now after that we'll go to the normal incidence. When you talk of the normal in the light, normal means a perpendicular. When you talk of the normal, it means we have to draw a perpendicular at a point. This is called as the normal. If we draw normal at the reflecting surface, this normal is called as this is normal or the perpendicular. So here I want to just, normal means the perpendicular, you have to understand. So what is the normal incidence? Normal incidence. So here, what is normal incidence? You see that if we take a plane mirror, okay, if we take a plane mirror, and when rays of light strikes at a plane mirror at an angle of 90 degree and its path coincide with the normal, okay, so the normal incidence take place. Okay, suppose here I have taken a plane mirror, alright, plane mirror, and here there is the normal also. There is a normal also, and normal means it will make an angle of 90 degree. On the normal, the path of incidence ray, they will also strike at an angle of 90 degree. That means they will coincide with the normal. They will coincide, they will move, they will come up over the normal. Its path of the incident ray coincide with the normal or perpendicular, and here and hence the normal incidence takes place. Okay, when the incident rays of light will coincide with the normal ray and makes an angle of 90 degree, then we can say that normal incidence takes place. And this ray, incident ray, is called as the normal incident ray, students. Okay, right? All right, now then we go to next thing now here. Okay, students, now we'll go to the inverted image. Inverted, anything upside down. If we go to anything, if we see anything, any kind of the image upside down, it is called as the inverted. Very simple method. If anything, any kind of image, if you see upside down, it is called as the inverted image, right? So in a simple language, you can say that the top side of the object will come at the bottom and the bottom will come at the top in the inverted image. Okay, top here, you see top is coming where? Top side is coming where? Top side is coming at the you see top side is coming where? Top side is coming at the bottom and the bottom side is coming at the top. This is the top side, this is the bottom side, okay, and here this is the top side and this is the bottom side. So now here this top side image will turn around its horizontal axis through an angle of 180 degree. Image will fully turn, okay, this will turn, whole thing, it will turn at an angle of 180 degree. It will turn at an angle of 180 degree, okay, 180 degree, 180 degree, that means this will come down and the top will come at the bottom and bottom will go to the top. So here, during inversion, the top side of the object appears at the bottom, top side will appear at the bottom of the bottom side of the image, and the vice versa means the bottom side will appear at the top. Hence the image turns around horizontal axis through an angle of 180 degree, then only this will go down and it will come up, okay, right? The top will go down and the bottom will come up, right? So this is called as the inverted image, right? Very simple. So after that we go to laterally inverted image. Now next one, we will go to the, you see, laterally inverted image. Now here, what is lateral? Lateral in the science means the side. Lateral means what? Lateral means lateral in the science. Very important point. Lateral means side. Lateral inversion means if the side of the image is inverted, is called as the lateral inversion. Okay. So now this is the phenomenon due to which the image of an object turns to an angle of 180 degree through vertical axis. We have seen that our inverted image has turned 180 degree through horizontal axis, but here it will turn to the vertical axis. Vertical. This is the vertex. No, this is vertex. This is called as the vertical. Okay, vertical axis. It will turn. Okay, in the vertical axis, right? So here we can say that the phenomenon due to which the image of an object turns to an angle of 180 degree okay, through the vertical axis rather than horizontal axis, such that the right side of the image appear on the left. You see, the right side is appearing on the left side. Okay, right side appear as the left, and left side appear at the right. Okay, the right side appear at the left here, and the left side appear at the right. Okay, right. So this is called as the lateral inversion, right? Laterally inverted image. All right. So after that we will go to last point our, that is the characteristic of image formed by a plan mirror. Suppose in your house we look at your face in the plan mirror, that is the looking glass, looking mirror we can say also. So what are the characteristic of image formed by a plan mirror? Suppose we get a plan mirror in the house where you can see your face early in the morning, is not it? After the bath, whenever you come in the house, you can see your face also, how it looks like, students. So here, characteristic of image formed by a plan mirror. In the plan mirror image, whatever image is a virtual image. Virtual image means it is erect. It is an erect image, and hence it can be taken on a screen. Hence it cannot be taken on a screen. Okay, image is virtual, and it cannot be taken on a screen. And image is erect. Image is erect also. Okay, image is of same size as the suppose object standing is here. This is 5 feet object is there. So here also the size of the image will be 5 feet, like that. Okay, so image is of same size as size of the object. This is object. Okay, and this is the image here. Image. Okay, this is the image, and this is the mirror. Okay, this is the mirror, right? So image is same size as the size of the object. Size of the object will equal to size of the image, or size of the image will be equal to size of the object. And image is laterally inverted. That means left side of the object appears at the right side of the image. Suppose you stand near a mirror. You stand near a mirror, move your right hand, and in the mirror you see that the left hand of the image is moving. If you move your left hand, you see in the mirror the right side of the image, the right hand of the image is moving. So this is called the lateral inversion. So image is now laterally inverted. Left side of the image, left side of the object appears at the right side of the image, and the right side of the object will appear at the left side of the image also. And image is formed as far behind at the plan mirror as the object is in front of it. Means if you stand in front of the mirror more and more, if you come closer to the mirror, the image form will be behind the mirror. It will go behind. Okay. If you stand a little bit distance from the mirror, away from the mirror, but to the side of the mirror, then image is coming in front. Okay. So these are the characteristics of the image formed by plan mirror. Very simple. Image is virtual, that means it cannot be taken on a screen. Secondly, image is erect. Image is same size as that of object. Image is laterally inverted, that is left side of the object appears at the right side of the image. I told you that if you move the right side of the hand, you see the image is moving left side, okay, of the hand of the image is moved. An image is formed as far behind the plan mirror as the object in front of it. Suppose you go in front of the mirror, plan mirror, the image is formed behind, right? And if you come away from the mirror, the image is formed in front. Okay, so with this we come to end of the chapter, reflection of light, students. And once again I request you to please subscribe the channel and share the okay. So student, now with this characteristic of image formed by a plan mirror, I have completed the chapter reflection of light. That is the first chapter of your physics, and we will go in the next class the second chapter, that is the reflection by spherical mirror. Okay, what is spherical mirror, and what are different terms associated with the spherical mirror, and how reflection takes place by the spherical mirror. There is a very important point important chapter in the light. So before I wind up here today, once again I remind you, or rather than I request you to please subscribe my channel and you share it with your friends also, so that they will be also getting benefited, because in the lockdown time they are sitting at home and then they can at least study something from the physics. And I am slowly moving the chapters, and after completing the physics, sometime I'll take the biology class also, sometime chemistry class also. Thank you very much for listening and watching this video. Thank you very much all my students. Thank you once again.